Hi guys, welcome back to my channel. Today's topic is CC 3.1 Welding Inspector, the latest question. You can get it from here with explanation. This is the part 8. There is part 1 to part 7. All these questions are very helpful. So please watch this video so you can get the clear knowledge of these questions. Hi guys, welcome back to my channel. This is Ananta with you. Today's topic is CC 3.1 Welding Inspector. The latest question you can get it from here with the explanation. So you know very well there is part 1 to part 7. The all questions are very helpful and it will be maybe it will become your exam. So let's start the part 8, but you should watch the part 1 to part 7. There are lots of questions. So they are the very important question. So let's start the part 8 now. So first question is the prior to commencing production welding using the MAG metal active gas, that is GMAW, you notice the earth clamp is in a very poor condition. What do you do? So first you should understand the questions what is telling. Means you are see somebody is welding using the MAG, but you see the earth clamp is not in proper condition, means poor condition. So as an inspector, what do you do? So let's see the option. A is nothing. You should means will not do nothing. B is insist the welder have it replaced before commencing welding, means you should say to welder that you should replace and then you should start the again welding. Okay, option B. Option C is it will not affect the welding, so wait until it eventually melts of the habit replace. Definitely it will not the correct answer. It will not affect the welding. It is affect the welding. I'll explain what is affecting will affect this welding for the earth clamp is very poor. Option D is it will be okay for welding but ensure that nobody touch it because they may get burned. So it is the safety issue also, but it is not the correct option. Option D. Option C and option D is not the correct answer. Option A also not correct answer. So option B will be the correct one. So option A no, option C no, option D also no. So correct answer will be the option B. Now we'll check the what is the explanation why we use this one, the option B correct one. First, you should know that all the welding current passes through the earth clamp. So, earth clamp is very important because all the welding current is passes through the earth clamp. Without a good earth connection, the performance of the welder and the welding machine will be compromised. So, if it is, you see, there is the earth clamp is very poor. So, the performance you cannot get the actual result. It will be compromised. This can only mean one thing, an inferior quality weld. So you cannot get the sound quality weld. Now, what is the actual reason technically? If a earth clamp is not in good condition, this will cause welding current leakage. So you have to know very well. If earth clamp is not in good condition, means it is in poor condition, definitely it causes the welding current leakage. If it is welding current leakage, definitely it will affect the drop in welding output voltage. So welding output voltage it is dropped, definitely it will sound welding, if you cannot get there, definitely the welding will be problem, which is like someone changing the setting on your welder means. So in current leakage, actually it will happen affect the cause of drop in a welding output voltage. So you understand now the option B is the correct answer. The question number 2, an advantage of the saw process is that, what is the advantage? It can be used in the vertical down position. It is not the advantage. Little or no ozone or UV light is produced. Definitely there is no UV light is produced in saw welding because the flux is there in over when the arc is generating at the time is flux is there at the same time, that's why UV light is not generating more. It can be the option correct, it can be the answer, but we need to check C and D. It is not affected by arc flow, it is not the correct one. It is not prone to solidification cracking. No, it is not. Saw process, definitely solidification cracking can be generated in saw process. So you need to check that here on screenshot is here. High current density, high deposition rate. What is the important thing for saw process? We can check here. High current density, high deposition rate, high productivity. Means current density is high, deposition rate also high for the welding metal. Also high productivity means production also is good. In production is also good. Deep penetration is there. Fast travel speed is there. Dislagging is easier means it is there is a spatter is there, but dislagging is very easy to remove the spatter. Uniform bead appearance with good surface finish can be easily performed mechanized. So mechanized welding by saw it is can be easily performed. Provide consistent quality when performed automatic and mechanized or mechanized. Virtually assured radiographically sound wells. Radiographically you can get the sound well. Arc is not visible, you cannot see the arc. Little smoke or fumes are developed. Very little and very little smoke you can see there. The correct answer is you can see this one. The UV light is produced is little, very little. So is not the right one. You can see very little smoke or fumes are developed means arc is not visible. So arc is not visible, that's why you cannot get the UV light produced is more. So option B is the correct one. Question number 3. Which type of submerged arc flux can be described as surf? So there is submerged arc flux. You can see the option agglomerated, fused, basic and neutral. Which one is the correct one? Note one thing you should know, the flaky or surf is the same. So flux may be categorized in two ways by the method of manufacturer. One is fused, another is or by its activity. One is methods by the manufacturer, that is called fused, another by its activity, that is neutral, active or alloying. So within this broad grouping, the flux may be classified further by their constituent: silica, manganese, oxide, calcium, fluoride, etc. So you should know the fused flux, what is this, and agglomerated flux. The fused flux, bulky appearance means the sharp appearance, lower weld quality, low moisture intake, low dust tendency, good recycling. You can recycle again this flux after finish the welding. Very smooth weld profile. So you see here the option here, flaky. So flaky means sharp. So which type of submerged arc flux can be described as sharp? So you have to, the option is fused flux means this flux. So this is not the correct one. So fused flux is the correct one. The option is, you can see B. Question number 4. Standard oxy-fuel gasketing equipment can be applied to. So oxy-fuel gasketing equipment where you can apply. One is aluminium alloys, B is carbon steel, C is austenitic stainless steel, D is copper. Definitely oxy-fuel gasketing you cannot use in stainless steel. No, you cannot use in copper. There is a copper oxide can be generated. So Aluminium alloys also you cannot use oxy-fuel. You see here, oxy-fuel no need for power supply. Okay, versatile preheat, brazing, surfacing, repair and straightening you can do this in oxy-fuel gas cutting. Low equipment cost is very low, can cut carbon and low alloy steel. So this can cut carbon and low alloy steel, so carbon steel. So the correct answer is carbon steel. Good for very thin material, it is good for the very thin material, this oxy-fuel gas cutting. Disadvantage, high skill factor, high skill required for this particular operation in oxy-fuel gas cutting. Wide hatch area is wide, safety issues is there, slow process is there, means very slow, limited range of consumable is limited, not suitable for reactive and refractory metals. So this is the advantage and disadvantages of oxy-fuel gas cutting. So you understand, the option B is the correct one. Which of the following alloying elements is used mainly to improve the toughness of steel? So which alloying element is used to improve the toughness? First is chrome, second is manganese, C is sulfur and D is carbon. Definitely for toughness, if you go iron Fe, carbon is C is for strength, manganese is for toughness, you see here. Silicon is for 0.3 less than deoxidizer, aluminium is for grain refiner, chromium is for corrosion. So every this alloying element have their own properties, own criteria. So manganese is for toughness. The correct answer will be the manganese. So you understand the question 5. The answer B is the correct one. Question 6. Weldment in carbon manganese steel made by low heat input welding may show. So you see that in a weldment of carbon manganese steel made by low heat inputs, what will happen? Greater ductility, high distortion, higher dilution, higher hardness. So you should know this one. Then now I will give the explanation. High heat input means slow cooling. You should understand. High heat input means slow cooling. Low heat input means fast cooling. So slow cooling, what will happen? If it is high heat input, slow cooling, it will be there. Low toughness will be there. Reduction in yield strength will be there. If it is low heat input in fast cooling, definitely the increase the hardness. Hardness will be increased. Hydrogen entrapment will be there. Lack of fusion will be there. So you see here made by low heat input they mention. So it should be increase the hardness, higher hardness. The correct answer will be the higher hardness, not greater ductility, higher distortion or higher dilution. So there is explanation also is there. A low heat input leads to rapid cooling as well deposited is small in relation to parent material. The parent material acts as a heat sink. The toughness can be low in microstructures that have arisen from rapid cooling rates. So rapid cooling rates you cannot get. Low in microstructure means you can see the increase the hardness. So martensite can be generated there. In general, very low heat inputs are to be avoided as they result in hard, crack susceptible microstructure with poor toughness. So you understand the question. You see here. Figure 1. Heat input influences coolant rate. This is the temperature. This is the temperature and this is the time. You see the higher heat input means slower cooling rate and this is the lower heat input means faster cooling rate. Simple is low heat input, faster cooling rate, higher hardness. Understand the option, answer D is the correct option, the higher hardness. Question number 7. Weldments in carbon manganese steel made using a heat input higher than the maximum specified the WPS. You see, the heat input, whatever is there in carbon manganese steel weldment, it is the maximum it is the more than the requirement heat input in the specified WPS. So what will happen? Higher integrity, lower distortion, the lower toughness, the higher hardness. Definitely high heat input is there. So high heat input is there means slow cooling. Slow cooling means the low toughness will be there. So lower toughness is the correct answer. So same thing, one is high heat input, another is the low heat input. The question is different. The answer C is the correct one. Question 8. Using a stabilized stainless steel will reduce the risk of. So you see, you are using a stabilized stainless steel. Stainless steel will reduce the risk. What the risk will be reduced? Excessive destruction, oil decay, formation of iron sulfides, and D is source service cracking. So you see here, things is there precaution of against oil decay using low carbon grade stainless steel 316L as the amount of the free carbon in solution is sufficiently low to ensure that chromium carbide formation is minimal and therefore that the sensitization is not usually a practically significant during welding. So you understand the answer will be the oil decay, not formation of the not source service. You understand the question. So stabilized grade stainless steel, that is 321, 347 and 380, 348 recommended for severe corrosive condition and high temperature operating condition containing Ti and Nb for carbide preferentially to chromium. So answer is option is B. So question 9. Which of the following microstructure is critical to the likely formation of hydrogen crack? Which is very critical to likely formation of the hydrogen crack? Austenite, ferrite, pearlite and the martensite. So which one is the correct one? Which microstructure? Definitely in the formation of the hydrogen crack, if you see the susceptible microstructure, that is called hard brittle structure, if so means martensite. Martensite is high carbon content, carbon equivalent, high alloy content and fast cooling rate. So the high brittle structure definitely will go for martensite. So it will not be the correct one. Correct answer is the martensite. Answer D is the correct one. Question 10. An arc strike on a high carbon steel plate is likely to have the following microstructure beneath surface. So which one is the correct answer? Austenite, martensite, ferrite and pearlite. Which one is the correct one? You see here, some steel if cooled quickly their structure looks like this. You see, if you cool like this, your structure will like be this way. Martensite can be defined as a susceptible solution of carbon in BCT iron body center tetragonal. It is the hardest structure you can produce in steel. So the correct answer will be answer B, the martensite. Means following microstructure is there. That's why high carbon steel plate. Even we record for martensite. The hardest phase in steel, which is produced by rapid cooling from the austenitic phase, that is called the martensite. It mainly occurs below 300 degrees centigrade. So the option is B, the correct answer. So you understand the all 10 questions with the explanation. If you have any query for the particular any questions, so you can just inbox me for this question. I can explain to you. So thanks a lot. Thanks for watching this video. Please like, share and subscribe my channel. Good day to get the regular video. Thanks a lot. Take care and goodbye.